All right, hello grade 12 chemistry students. This is our third in a series of videos about organic compounds. These are, again, compounds that you are likely familiar with because we talked about them before we left for March break. These are all compounds that contain oxygen. Alcohols, aldehydes, and ketones are what we're going to be talking about today. And you'll notice that the thing that they all have in common is they have an oxygen somewhere in the molecule. So the first type of compound we're going to talk about, alcohols, have an OH group. So you've got your chain of carbons like any organic compound, and then on at least one of the carbons, you've got an oxygen and a hydrogen together. We can recognize the names of alcohols because their names end in OL. Okay, so an example of that would be ethanol, which is actually, when we talk about alcohol in beverages, we're talking about ethanol. Okay, and it comes from fermenting sugars. That's how things like beer and wine are made. And ethanol, so hopefully you'll remember, and if you haven't already, I really do recommend making up one of these keys for yourself. So this tells you the prefix that we might find in the name of an organic compound and how many carbons it represents. So F represents 2 carbons. So ethanol is an alcohol that has 2 carbons. And then we can see that it's an alcohol because it's got one of those OH groups. And you might also see this drawn as this type of structure. Okay, so 1, 2 carbons, and then the OH group. Okay, so we'll go through an example of how to write a name, structure, and a skeletal diagram, and then I'll give you guys some example questions posted with this so you can practice your naming and drawing a little bit at the end. Okay, so if I go back to my little key here, I'm just going to make up an alcohol. Let's say I want to do heptane. Okay, so not heptane, but heptanol. So hept means 7 carbons, and then if I put hept, and then if I put anol, okay, that tells me that it's an alcohol, but 7 carbons is a lot of carbons. There's a lot of different places that I might put that alcohol group on there. So I left a little space here. I'm going to just give a number to say where that alcohol group is. So heptan3-ol tells me that my alcohol group is going to be on the 3rd carbon in the chain. Because remember, when we see numbers in names, it just tells us the position of a functional group, okay? The position of something. So to draw the structure of heptan3-ol, I'm going to start by drawing 7 carbons, because hept, you'll remember, hept means 7. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, and then the 3 here tells me that I've got a functional group. I've got something cool going on my 3rd carbon. So I'm going to count starting here. This is carbon 1, carbon 2, carbon 3, and I'm going to put my OH right there on the 3rd carbon. Okay, and then you'll remember that each carbon has to make 4 bonds. So I'm going to make sure every carbon's making 4 bonds by adding hydrogens to all the carbons that still have bonding spots. So this carbon right here, it's only making 1 bond, so it's going to need 3 hydrogens. And then this one needs 2. And then this one's already making this bond to oxygen, so it only needs 1 hydrogen. 2 here, 2 here, 2 here, and then 3 on the end one. Now, obviously, it's getting kind of tedious to draw all those hydrogens. So an alternative way of drawing our structure is called a skeletal structure. And it's kind of like the one I drew up here, where you show just sticks to represent the carbon chain. And then anything that's a hydrogen is just sort of implied here. I don't actually have to draw the hydrogens in. So if I was drawing a skeletal structure of heptan3-ol, I would start, I count 1 when I put my pen down, 2, 3, 4, 5, 6, 7. So that's 1, 2, 3, 4, 5, 6, 7 carbons. And then on my 3rd carbon, I need to show that alcohol group, that OH. And then that's it, heptan3-ol. Okay, So that's the name right there, and then that's two different ways of drawing it. And remember, when you're answering questions and when you're asked to draw structures, I don't care. You can draw them like this, showing everything very clearly, or you can draw them as the skeletal structures. A little bit harder to understand, but much faster to draw. Okay. Going to move on to the other side of the page here. We're going to talk about aldehydes and ketones. Now, aldehydes and ketones are actually very similar. They both have a carbon double bonded to oxygen. Okay, so you'll notice that they have that in common. The difference between an aldehyde and a ketone is actually kind of a subtle one. It depends on where the oxygen is. If the oxygen is on the end of the molecule, then we consider that an aldehyde. Whereas if it's in the middle of the molecule, we consider it a ketone. Okay, so in both these cases, I've got two structures here, and you can see that each structure has 3 carbons. Okay, and each structure has this double bond to oxygen. So they're very, very similar. However, this one has the double bond to oxygen in the middle of the chain, which is what makes it a ketone. This one here has the double bond to oxygen on the end of the chain, which makes it an aldehyde. Okay? So we're going to go through some examples here. We'll come up with an aldehyde name, and then we'll draw its structure 2 ways, and then we'll do the same thing for a ketone. Now, aldehydes, we'd never see numbers in the name of aldehydes because we know that the carbon double bonded to oxygen has to be on the end of the chain. So I can just pick any of my prefixes here. Let's say I'm going to do pent. And then I'm just putting anal, I pronounce this anal, on the end of the name. And that's what tells me it's an aldehyde. So this ending to the name corresponds to aldehyde. Okay, so the structure of pentanal. So pent, if I remember here, means 5 carbons. So I'm going to draw 5 carbons. 1, 2, 3, 4, 5. And then because it's an aldehyde, I know that one of the end carbons, and I can either pick this one or this one, because they're both end carbons, but one of those has a double bond to oxygen. Okay, then the last thing I need to do is just fill everything's bonding spots with hydrogens. Okay, so making sure that every carbon is making 4 bonds. And then I want to double check this carbon right here. It's actually already making 3 bonds because it's got this double bond to oxygen. So it only needs 1 hydrogen, not 2. Okay, the skeletal structure for this, also pretty straightforward. I count 1 when I first put my pen or pencil down, 2, 3, 4, 5, because I need 5 carbons. And then my carbon on the end has a double bond to oxygen. Okay, so pentanal, that's what the structure looks like, or if I drew a skeletal structure like that. All right, and then our last thing for this video is to come up with an example of a ketone. Okay, so I'm gonna once again pick a prefix. In this case, let's do hex. Okay, so that means 6 carbons. And then if a compound is a ketone, the ending is O-N-E, so hexanone. Okay, now, similar to the example we had on the previous page, there's a bunch of middle carbons that could have the ketone group on them. So I actually need a number in this name, and I should have left a little more space so I could do that. But let's say, so I can't put because it's a ketone, it has to be somewhere in the middle of the chain. So I can't put my ketone group on carbon 1 or carbon 6. But any of the ones in the middle, carbons 2, 3, etc., are fair game. So I'm going to say it's hexan-2-one. Okay, and maybe I'll write that name out again so it looks a little nicer. Hexan-2-one. And then I'm given a direction in the name where exactly to put that ketone group. So if I'm drawing my structure, 1, 2, 3, 4, 5, 6 carbons, and then my ketone group is going to go on carbon number 2. Then I fill everything up with hydrogens, like so. This carbon is already making 1, 2, 3, 4 bonds, so it actually doesn't need any hydrogens. So I can skip over that one, fill up, starting here. Okay. Okay, and then my very last thing here, I'm going to provide a skeletal diagram, just so you have that kind of easier way of drawing. So 1, 2, 3, 4, 5, 6 carbons, and then I've got my ketone group on carbon number 2, so 1, 2. Okay, and that would be the skeletal structure for hexane 2O. Okay, thanks for watching. So that covered 3 of our different types of organic compounds. On the previous page, we had alcohols right there, which have an OH group. And then on the second page, we had aldehydes, very nice, which have a double bond to oxygen on the end. And then we had ketones, very similar to aldehydes, but they have a double bond to oxygen somewhere in the middle. Okay, thanks for watching, and please try the practice questions I've attached.